What's up YouTube? Welcome back to another tech video. Today I will be showcasing the Battleship game that I have made using only Microbits. This project is a faithful adaptation of the classic Battleship game, so let's dive on in. Here I am showcasing how one of the player modules would work. As you can see, you can just move around the microbit using A and B, and it shows where your current location is. The second one will show where your ships are located, and the third one will show whether you hit a ship. So, when you press A and B together, it will say sent, and you will see that it has missed the ship. This next video showcases how it would all work when they're lined up. The first three microbits on the left are for player 1, and on the right it's for player 2. You can see I've got it set up. It's going to send ship, and it's going to give a smiley face because you've hit your opponent's ship. Now, on the opposite player's one, it's also going to hit the ship. This final video showcases how it would all go together. Each player would have their own ship placement above, and they would have their controls for hitting the opponent's ship below. And out on the right side, you'd be able to see whether a ship has been hit or not with the smiley faces and frowny faces. This goes along with the original game setup where they have two boards facing each other where you can only see where your own ship placement is. And then out the back, you have the smiley faces and frowny faces coming off so that you can see when the ship has been hit. You can see I have the code for the microbit number 1. So you can see how you just will navigate around the screen like this, and when you're ready to send a shot, you press A and B, and it'll tell you that it's sent. So this will be on radio group 1. So player 1 has 2 modules on radio 1 and 1 on radio 2. So when it's like this, it will communicate with the other microbit, which is storing the opponent's ship placements. And so how the code all works is, I think it's easy to run through on Python, is that this is basically displaying where your current position is as you navigate through as such. And here is just defining how you move through this one and as well as this one. So they're just saying that when you're pressing these, you're changing positions according to that. And this section of code is just saying that when you press A and B, it will show the string of send here, and it will also set your guess to be broadcasted. Oh, here. Oh, yeah, you broadcast the guess with this, and then this shows that it has been sent. Now, these are just a few defining variables. So you got to define X and Y to start at 0, 0 up here. And then you've got the guess defined, just so you can send the guess when you click them. And then make sure the radio is on for group 1. Here I have the code for the second microbit that player 1 has. This one stores all of the values of where their ships are. And so it is a part of radio group 2, so that it can communicate with player 2's guessing microbit, and they can guess where the ship positions are. And so here is just the array of where the positions will be. So we'll jump into the Python code so it's easy to run through. Here we've got a function that displays where the ships are. And so it runs through a loop. It runs through the whole array where it will choose out every X and Y value and plot them. So that way, if I go down to the array here, plotting different values on this, will allow you to change, there you go, it's changed from there to there. Just change the positions of your ships. And so here we have another function that checks the hit guess. So it will either return a hit or a miss depending on where they have guessed. So obviously, if they've guessed in any of these 3 lit up spots, it is going to return a hit, otherwise it will be a miss. So the way that works is it gets the global guess X, guess Y that will be sent as was shown in the first microbit showcase, and then simply splits the coords up and then get checks for X and Y separately after they've been split up, and then checks if it matches. And so here's another function for when it has received a string, it will check the result, send the result, yeah. And then here's just all the variables defined. So we have to define results so that there's something to fill, define the guesses, and this just all for use in the functions. And yeah, basically just all for being used in the functions. All right, so here you can see the code for the final microbit that player 1 has. So I will just run through it real quick. This one, very simple. Its only job is to display whether the ship has been hit or not. So it just has the function for receiving the hit value from microbit 2. So if it has received a hit, then it will show the smiley face icon as you have seen in the videos shown earlier. And if it has received a miss, it will show the sad face icon. And so this is a part of radio group 1 as it is communicating with the player 1's guessing one and player 2's microbit that holds the values for ship placement. So that's the whole showcase. As you can imagine, the code for player 2's 3 microbits, they are all practically identical except with the radio group inverted, so that this can create pretty much 2 networks. So you've got basically a cloud type of network where all of the checking for hits is done on the microbit, which stores the values for the ship placements. So that will receive the sent coordinates for where you have tried to hit a ship. It will check whether it is hit, and it will send it back to the last one, which will display the smiley face or the frowny face. So that is how it incorporates the cloud networking. And for the edge networking, that would be with the smiley face projecting up. That is on the same radio group as the hit sender as well. So those 2 have communicated within themselves without the middleman of the cloud server as well.